Today we'll be preparing chelidonic acid, an interesting heterocyclic compound synthesized by the reaction of acetone and diethyloxalate in the presence of a strong base. We've drawn up the reaction scheme here so you can see how the carbons in the target molecule originate. It's apparently useful to keep water out of the first stage of the reaction, so we used an oven-dried 250 ml flask and Teflon magnetic stir bar. We weighed out 14 g of sodium ethoxide directly into the dry flask. This is a slight excess to what we need. We prepared this reagent in a previous video. For more details, click the link shown. We want to dissolve this in the minimum amount of ethanol possible, so we're going to start with 30 ml and see how we go. Add the dry absolute ethanol to the flask. And then gently start stirring to get it to dissolve. We added another 10 ml of ethanol and most of the solid dissolved after 10 minutes. Now for the diethyloxalate. We had some difficulty drying this because we discovered that over a period of time this compound has a habit of reacting with calcium chloride. We're not totally sure what happens, but it gives off a lot of HCl fumes. So we washed the diethyloxalate thoroughly with brine and then dried it for a few days using anhydrous magnesium sulfate. Hopefully this will be dry enough. We decanted the liquid and weighed out 26 grams of diethyloxalate with a sickly sweet fruity aroma. And then added this to the flask containing our sodium ethoxide solution. At this point the remaining sodium ethoxide solid went into solution. Next we measured out 5.2 grams of dry acetone from a fresh bottle. And we added 20 ml of absolute ethanol to this in order to make up a solution. We then set up the flask with a dry pressure equalized addition funnel on top. If you're using a non-pressure equalized one, you'll need some sort of vent from the flask to allow pressure to escape. We added the acetone in ethanol solution to this. Then with stirring on at room temperature, we started a very slow addition of the acetone solution to the reaction mixture. We went slowly because too much of an acetone concentration in the mixture can cause side reactions. We want to keep the other reactants in large excess while the acetone is deprotonated and reacts. Our aim was for complete addition to take around 40 minutes, and with a small volume of liquid to add this meant a slow drop rate. The first sign of the reaction occurring was a slight yellow tint and a milky color appearing in the mixture. Soon this became much more intense, as you can see. We could also see a precipitate building up in the liquid. Here we are halfway through the addition, and at this point we switched on the heating so that the temperature of the mixture could slowly rise during the second half of the addition. By the end of the addition the temperature was around 60 degrees C. And about 40 minutes in the addition is complete. At this stage we removed the addition funnel and placed a thermometer in the reaction mixture to monitor the temperature. We brought the temperature up to between 70 and 75 degrees C, and then held the reaction mixture at this point with stirring for an hour. During this period the color darkened slightly and the mixture became thicker as more precipitate was deposited, as you can see here. After an hour we allowed the mixture to cool and then left it overnight. The next day the mixture was quite dense and could only just be stirred magnetically. At this point we chilled the flask down to 0 degrees C. We placed 25 ml of concentrated hydrochloric acid into a small beaker, and also chilled this down to as cold as we could get. Then we set up a dropper so we could add it slowly. And with the cold reaction mixture stirred as well as we could, we slowly added the cold concentrated hydrochloric acid. By the end of the addition the temperature was around 20 degrees C, and the mixture had turned an orange color. As you can see, a fairly heavy orange-colored precipitate formed. And we checked the pH of the mixture to make sure it was strongly acid and all base had been neutralized. We then filtered the precipitate off using a vacuum pump. The filtrate liquid was an intense red color with a yellow tin, and as a warning it stained everything it touched yellow, including the glass. We washed out the flask with 20 ml of ice water and then used this to wash the precipitate. Drying took several hours on the pump, but we ended up with 13.5 grams of an orange solid intermediate. This is our acetone double addition product. Now for the next step of the reaction, which is to hydrolyze the ester groups in this molecule and cyclase the compound into chelidonic acid. In hindsight we could probably increase the yield by boiling the ethanol off the filtrate and seeing if we could collect more product. This might be something to try if you feel inclined. But watch out for the yellow stains. This stuff takes no prisoners. Okay, now for part 2. We set up a 250 ml flask equipped with a magnetic stir bar and added our 13.5 grams of intermediate product to this. Then we measured out 40 ml of concentrated hydrochloric acid and added this to the flask. Then we set this up on a hot plate stirrer with a reflux condenser attached. We're going to need to heat this for a while in order to get all hydrolysis to occur, and fumes of HCl will be given off, so make sure you use ventilation. We initially heated the mixture to reflux point for 2 hours. There was a little bit of foaming in the flask, but not too much. We noticed the orange precipitate change to a tan color, and then into a microcrystalline form. After 2 hours of refluxing we added an additional 10 ml of concentrated hydrochloric acid through the top of the condenser, and then refluxed for a further hour. And then after an hour we removed the condenser and allowed the mixture to boil off a little bit. Since acid ester hydrolysis is a reversible reaction, we need to drive off the ethanol in order to get this to completion. Total heating and hydrolysis time was 4 hours. Towards the end of heating we noticed that the mixture bubbled and foamed quite a lot, and the color darkened. The dark but slightly opalescent flaky material was seen on the sides of the flask. We chilled the flask down to 0 degrees, which seemed to increase the amount of solid present, and set up for filtration. It took a bit of work with a spatula to transfer it. We then washed out the chilled flask with 10 ml of ice-cold water and used this to wash the precipitate in the filter. Then we allowed the brown solid to dry thoroughly on the pump. The resulting brown paste was then oven dried at 120 degrees C to form a solid. Here's the fully dried product. 8.4 grams of a light brown fine powder, At 120 degrees drying temperature, we believe that this should be chelidonic acid monohydrate. If so, this would give a yield from the starting acetone of 47%. If it's the dehydrated acid, then the yield is 51%, so in reality it probably lies between these. We're going to attempt to convert this into chelidonic acid by introducing a nitrogen into the ring. This will be exciting because if it works it will give us a pyridine compound synthesized from relatively OTC starting materials. So stay tuned.